technology in the future cloud. Before I start, I want to ask each and every one of you to think about how many mobile devices or wearable devices do you have right now with you which are connected to the internet? Count these devices. Now, add the number of devices which you have at home which are connected to the internet. You, sir, how many devices did you count?
More than 30.
More than 30. Okay, that's quite much. Didn't expect that.
Yeah. I know my wife doesn't like that either.
Okay, so currently we have like 15 billion devices in the Internet of Things field which are connected to the internet right now. And market research conducted by Intel shows that by the year 2020 we're going to have 31 billion devices which are going to connect to the internet among 4 billion people who have daily access to the internet. Currently we have a topology which is more like this. That means devices are connected, mostly sensors, in a more centralized way. But researchers mostly agree that we have a chaos like this in the future, which means devices are not connected to a server, but rather to many other devices in order to share information, to interact with each other, and to improve the services. Now, who's interested in this field actually? Well, our target customers are mostly research institutes, and of course also universities and companies who are doing heavy research on the field of Internet of Things and sensor networks. And we have also talked to some of these, and we're getting back to that later. Now, what do we want to do? We want to ease the market entrance for new companies and new products. We also want to accelerate, especially testing and also the developing phase of the product development. And thirdly, we want to enable new companies or smaller companies to realize low-budget projects. Now, consider, for example, Apple wanting to introduce a new product, let's say the iChair. iChair wants to determine in a room who has the highest body weight. So they have to communicate with each other. This is the field where we want to focus on. That means before Apple can deploy this product, they have to test it on a test bed. And what our product actually does is my colleague will tell you right now.
Yeah. So in short, our product is a test bed for Internet of Things applications. So how are the companies or the research institutes doing the testing for Internet of Things in today's market? First of all, they are using simulations or emulations and extrapolations for testing the applications. But consider a scale wherein 31 billion devices are talking to each other. You can't rely on the simulated result. You want to get the applications working on the real hardware, and you want to test the data which is working on the real hardware. Thirdly, they have limited scalability. That is, they have very less number of devices, for example 30, and then they just extrapolate the data to 300 or 3000 devices, which is not 100% accurate. What we want to do is we want to provide the companies with 100% accurate results. Now, when we talk about devices in Internet of Things, what exactly I mean? Each device has three common things. It has antenna or a wireless radio which allows the device to talk to other devices. It has processors which hosts the operating system and the source code of the application developers. And it has sensors which allows the device to talk to the environment, get the data which is processed and communicated by the device. So for all this time, you guys must be wondering, what is our real product? Well, our real product is this. We will provide a cloud of devices in a flexible topologies so that the companies can get a full-fledged access to 10,000 devices in the coming 4 years. They will be allowed to select any topology they want. They will be able to select any operating system, any generic operating system to load on these devices. They will be able to load the source code and get the exact data on the real hardware. This cloud will be connected to another cloud, for example, which we rent from Amazon. So that's why our name is CloudCeption, because a cloud of devices is connected to a real cloud. A remote user, for example, a researcher sitting at a place, can get the access of our infrastructure through a very nice GUI to select the number of nodes he wants, to select the operating system, and to deploy the application. Well, the financial aspects now will be covered by David. Before that, I just want to tell what are the real advantages of our thing. We provide real-time data. That is, we allow to simulate points in real time. We allow you to deploy the OS and the source code on the real hardware. We allow you high scalability, that is providing 10,000 nodes, and our infrastructure is really, really flexible. It allows you to select any operating system and any topology is possible.
Thank you very much. Maybe like I do, many of you believe that behind every great business idea there must be a great financial plan. And that's why there's a big focus on the financial plan. This is a revenue model. It comes from a formula with a lot of variables. But overall, since we are offering services similar to Amazon, Amazon is renting servers, we are renting sensor networks. One of the main variables in this formula comes from how many hours you are using our sensor networks. And with this revenue model, we come with the following financial plan. What do we need? We need an initial investment to buy infrastructure of 300,000 euros, which we are planning to get from a loan from KfW, a bank in Germany specialized in startups. Then we will start running our business, and we will need a little funding, around $200,000, which we plan to get in the venture capital. We will reach the break-even in the second year, and then in the third year, the net profit will be positive. Now, as a small startup, it's always nice to have some backup. So, Public Relationships Officer, Mr. Mustafa, spoke with the people from Fraunhofer, and they gave us a great feedback. They say, hey, we love your product, and should you build it in reality, we will be your first customers, which makes us feel very good about it. There is some competition out there, which I will be very happy to speak about in the Q&A if you're interested about it. And this is the team that is making CloudCeption possible. It's an amazing team. And to summarize, CloudCeption believes in a better future, and we want to help you build it. Thank you very much.
I guess, so are you gonna pay all for that hardware yourself? So as a startup, so that sounds like 10,000 devices that.
That's the goal.
Yeah, actually, the good news is my friends are along with me. We are really working on this project, and we have made the nodes so cheap that you will be able to deploy 4 operating systems on a node which just costs $10 to $15. Currently, the price we have estimated is $12, but we are planning to get it down to $10. So it will be just $10 into 10,000.
And from a financial perspective, I would say that, of course, the investment required to buy 10,000 nodes is too great. So the financial plan, it's already thought that we are going to buy it in batches. The first batch will be 1,000 nodes, the first year, then 3,000 nodes. So we're going to increase the number of sensors because otherwise the initial investment will be too big for us. That's why you see that the expenses were like this, kind of exponentially.
So you're assuming that that there's some kind of standardized hardware that the IoT devices will be using. So can you elaborate?
Yeah, basically every Internet of Things hardware is based on wireless sensor networks. And wireless sensor networks basically relies on 4 basic operating systems. There is something called as TinyOS, there is something called as Contiki, there is FreeRTOS, and embedded Linux. Now, there is a very unique way we have found to port any of these 4 OSs into a flexible controller which we have found. The controller's name is MSP430, and it allows to port any of these 4 basic operating systems which most of the companies and the research institutes use to build any Internet of Things and sensor networks applications. So these 4 operating systems are constant, which will provide the customer, and any of these they can use to port into the hardware.
But that's not the question. The hardware is the sensors that are all living their own life, new sensors being added up and so on, to be able to simulate or use your system as a test bed. You need to have those sensors.
Yeah, actually any sensor data is a stream of bits. So if we just make a standard sensor and the customer can select how the stream of bits is going in, then it's the exact sensor, which is it. Because you consider any sensor, it will give out a stream of bits, whatever sensor it is. So it doesn't really matter what exactly the sensor is, because this is a testing scenario. The need of sensor is to estimate how much energy the sensor is consuming. The real need is not exact what data it is, but for the customers, they want to know how much energy the sensor is using, if the sensor is running for this much amount of time, when the node will die, and if the node dies, what is the effect on the network. We want to allow the customers to use these 3 things. It doesn't matter in reality what is the sensor. It matters what is the data and what is the energy effect of it.
Yeah, have actually working in the fields, also racing conditions and so on are some quite challenging things where you actually don't know what happened and why this whole system came down. So where you don't know the behind the exact strengths.
So perhaps you can become our second customer.
Well, I saw many of the ventures here related to connecting of things. For example, the company which allows to make devices which will help kids. What about the device if we can connect and speak to other devices which other kids have? So testing for such kind of scenarios, which will be needed in the coming years, we will provide the solution for them.
Any other questions?
Actually, something had some really good comments, but what I really liked about what you're doing is that you have a customer, and that's a huge thing. One customer, not more than one, but one really important customer. That's a great